Hello everyone. Today we are going to look at tree traversals. What's a traversal? Traversal is a certain way of reading a tree, and today we're going to learn one of the ways to read a tree, and that's a postorder traversal. We are going to start with left child of the tree. So the left child of the tree, if this is a root, the left child is here, the right child is here, and the way we read it is always from left child, right child, and then the root. So here is how we read this one. A, B, R. When we look at more complicated graphs, you will always look where the root is. You will see the left side of the tree and then the right side of the tree. This child is a parent, so left child, right child, parent. So the way to read this one is start here, D, go to E, and then B. When we walk to the right side of the tree, start with the left. Here's the parent, and finally the root. So postorder traversal, we start at D, E, B, then we went all the way to the right side, the bottom left child, parent, and then the root. When we have a binary tree, it's an expression tree, we can also read the postorder traversal. And again, there is a left side and a right side of the tree. We are going to start on the left. The left child is a 4, so we're going to start here, then not the right, but you're going to go left and then go this way. So 4, 8, 6 minus multiplication, then all the way to the right side. This is the left child. You can't read the right child yet. This is the left child, right child, operation, operation, and the root. So on the right side, we're going to have 5, 2, 3, multiplication, addition, and addition. This is the postorder for this binary tree. If you would actually evaluate this binary tree, just using the operations in the bottom, start at the bottom and using the operations, you should get 19. So that's a 2, 8 minus 6, 4 times 2 is 8, 2 times 3 is 6, 5 plus 6 is 11, so 8 plus 11 is 19. This notation right here, you can also evaluate this expression, postorder traversal, and we will going to use a reverse Polish notation. So it's kind of strange looking. There is no parentheses. You don't know which operations to do first, but there is a procedure, of course. So when you go from left to right, you look at the first operation and circle the two numbers. This means 8 minus 6. So when you rewrite it, this would be a 2. You keep going with the other operations, and right here we can also do multiplication. So this will be a 6. Okay, so this is gone, and we're gonna go plus plus. Then the next line, there's two numbers on operation, and we're gonna multiply. So this is 8. Then the next 2 with the operation is 5 plus 6, which is 11, and then the plus on the end. As you can see, 8 plus 11, this would be your last operation. This would equal 19, and this is reverse Polish notation. Let's do another example. First, we're going to write the postorder of this binary tree. So this is your left and right. You're going to start at the left child, and left child, operation, operation. Let's write this down. 5, 8, multiply, division. And now we are ready to go to the right side. So here's 6 operation, right child, operation, and operation. So right here on the right side, we start with 6, 2 minus, then the right child, which is a 3, then a minus. If you actually find the answer to this binary tree, this should be 3. So we're going to do that using reverse Polish notation. So there's no parentheses, but we will get a 3 out of this. And this is the procedure. One more time. 5 times 8 would be 40. Then the next two, 7 minus 3, that would be 4. This division needs to stay. The next two numbers, 6 minus 2, that's a 4. 3 will stay, plus and a minus. So here's the next two. 4 divided by 4, 40 divided by 4 is 10. 4 plus 3 is 7. And there's your minus. 10 minus 7 gives you 3. Okay, now we're going to use reverse Polish notation without the binary tree. So this is an expression with no parentheses. As you saw in the previous example, we should find first operation and circle the two numbers in front. So this one and this one. We can do these operations at the same time. So 4. 8 minus 6 is 2. You need to write the multiplication. Have to have that 5. And then 2 times 3 is 6. And then plus, plus. The next two numbers, 4 and 2, which is times. So 8, 5, and 6. That's addition. That would be 11. And we're going to add. 8 plus 11 is 19. As you notice, this is exactly the same problem as we had prior with the binary tree. Let's do another one. Maybe let's do this one. There's no parentheses, but we know exactly what to do. So 4 plus 3 is 7, 8 minus 2 is 6. We need to write the plus, 4 plus, and a 3 and a minus. And then the other two is 7 plus 6, so that will be 13. There's your 4 plus 3 minus. There's your other two numbers. 13 plus 4 is 17, and there's your 3. 17 minus 3 is 14. That's reverse Polish notation.